When you're multiplying rational expressions, you want to make sure that you factor every numerator and every denominator before you start to cancel out like terms. So in this first one, 2x minus 8, we're going to factor that. So we're going to take out the GCF, which is 2. We're left with x minus 4. Now that denominator, x squared minus 16, we're going to factor that. It's difference of squares, so x plus 4, x minus 4. And the next numerator multiplies to 4, adds to 5, so we're going to use 4 and 1. So x plus 4, x plus 1. Now that denominator multiplies to 16 and adds to 8. We're going to use x plus 4 and x plus 4. Now when we're canceling out like terms, again, each term has to have a matching term on an opposite level. So you can never cancel out things next to each other. So in the second denominator, this x plus 4, you can't cancel both of those out. So we're going to look to see on two levels what is the same. So we have an x minus 4 here and an x minus 4 here. We have an x plus 4 here, and now we can choose any of the 3x plus 4s. You can't cancel all of them out. So let's just cancel that one out. They can be opposite, they just have to be on opposite levels. So if one's on the top, one has to be on the bottom, either directly underneath it or in the fraction that's next to it. So now what we're left with is the 2 and the x plus 1. And on the bottom, we have x plus 4 and x plus 4. Okay, and you can leave them just like that. You don't have to FOIL it back out. So this is simplest form. You can FOIL it if you would like to, but you just need to get it to here. Then you're going to state your restrictions. So again, you're stating your restrictions on your denominators, and we have two denominators now. So all two denominators we're going to have restrictions from. So if we look at this one, if we set that to 0, we'll say x can't be negative 4. This one, x can't be positive 4. When we go to these, they repeat. So that's the same as that, and that's the same as that. So if they repeat, you only need to write it once. So our restrictions are that x cannot equal negative 4 and x cannot equal positive 4. So if we look at these, okay, first, again, we want to make sure that we factor anything that we can first. In this first example, we can't factor, so we're just going to reduce. So we can reduce up and down. We can also reduce diagonally. So if we look at the 4x squared, I can reduce that with the 12x to the 4th. So this 4 is going to go away and become a 1. This 12 is going to become a 3, because I've reduced that by dividing both by 4. With the x squareds, I can get rid of this x squared, and that would be a 1. And this x to the 4th is going to become x squared. Now, diagonally the other way, 7 and 5 you can't reduce, but the y's you can cancel out. So what we have right now is we have 1 over 5 times 7 over 3x squared. So here we're just going to multiply them right across. So 7 times 15x squared. So that's our simplest form. And then again, we're going to take all the denominators and set them to 0. So we have x can't be 0, and y can't be 0. And the second one, so for this one, we're going to take out a GCF of the top. So 8y minus 4 has a 4 in common, and we're left with 2y minus 1. The denominator, we could take out a 5, and we're left with a 2y minus 1. The next numerator, we can take out a 5, and we're left with a y minus 3. And then the last denominator, we can take out a 3. That's our GCF, and we're left with y minus 3. So now when we go to cancel, the y minus 3s are going to cancel out, the 2y minus 1s are going to cancel out, and then I can diagonally cancel out the 5s. So what I have left is just 4 over 3. And then our restrictions, we're going to set both denominators to 0. So y cannot equal 1/2, and y cannot equal 3. And then this last one, x squared minus 4, we're going to factor that with difference of squares. So that's going to be x plus 2 and x minus 2. The denominator over there, x squared minus 1, again is difference of squares. So that's going to become x plus 1, x minus 1. This numerator will stay the same. Then the denominator, we can take out a GCF of x, and we're left with x plus 2. So now when we look to cancel things out, we can cancel out this x plus 1, because they're on opposite levels, and I can cancel out the x plus 2's. So what we're left with is an x minus 2 in the numerator, and then we have an x and an x minus 1 in the denominator. So for our restrictions, again, we're taking everything that was in the denominator, even if it was canceled out. So if we take this, x cannot equal negative 1. If we take this, x cannot equal positive 1. If we take this, x cannot equal 0. And we take this one, x cannot equal negative 2. So this has 4 domain restrictions.